Let's walk through a case study at a food and beverage plant in Dallas, Texas. This is a food and beverage plant that produces bottles and fills those bottles with liquid in Dallas, Texas. There's 11,000 tons of cooling here, all within one centralized unit. So at this site in 2024, they saved just over 19.3 million gallons of water in their cooling system and $142,000. The way that we're going to do this is by increasing cycles of concentration and utilizing RO concentrate as our feed water. All right, this is what the system looked like when we got there. Two separate systems. We've got the process water system. It's using the reverse osmosis to remove all of the mineral concentration for the water so that we have pure product water going to the product where we can fill that with sugars and salts. We call that the permeate. The water that comes off of the RO, the reverse osmosis system, that is the wastewater, is called the concentrate. And then we have a separate, completely separate system for the cooling system. We were using all city water to the tower. They were running just over 2 cycles of concentration and using 3 separate chemical feeds, a scale corrosion inhibitor to protect from scale and corrosion, and then a non-oxidizing and oxidizing biocide for bacteria. So what we did when we got there was we installed a pre-RO set of softeners. This does 2 separate things. One, it removes all of the hardness minerals from that water going to the RO and puts less strain on the RO membranes. This leads to less maintenance costs and less replacement costs for the RO. It also removes that hardness minerals so that we're sending water that's void of hardness minerals back to our system, which we'll show you here in a second. The second step is we tee off of the concentrate and collect that RO concentrate, that wastewater, in this storage tank. You can see here that we're also supplementing with city water if for whatever reason that RO concentrate is not available. We don't want to run the tower dry because of that. Next, we're going to repressurize that water and send it to a second set of polishing softeners. These softeners are going to remove all of the hardness minerals and then send that water to the tower. When we remove the hardness minerals, we remove the building blocks for scale. And so we're able to increase our cycles of concentration and use the natural chemistry of the water for corrosion and bacteria. Before we got there, they were consuming a little over 19 million gallons and running about 2 cycles of concentration. So they're sending about 9.6 million gallons to the drain. After we got there, we increased cycles of concentration to just north of 20 cycles or less than 5% blowdown, saving in that 8 million gallons a year range. But remember, we aren't sending city water to the tower anymore. We're sending RO concentrate, or once was wastewater, that's been recollected, repressurized, and sent to the towers. But remember, we aren't sending city water to the tower anymore. We're taking the once was wastewater from the RO, repressurizing that, and sending it to the tower. So instead of using 11.5 million of city water, we're actually using only 69 gallons of city water in the tower, saving us in that 19 million gallons of water a year range.